Hello, everyone. Let's get started for this problem. Search for a range from scratch. So let me try to understand the problem. So given a sorted array of integers, find the starting and ending position of a given target value. The algorithm runtime complexity must be in order of O log n. If the target is not found in the array, return -1, -1. So here are some examples. So my input would be a sorted. So I have two input actually. So one is a sorted array of a sorted integer array. And also I have a target value. So my output would be the starting position or starting index of the target value as well as the ending index of the target value. So it says my algorithm needs to be in O of n, run O of n. Time complexity. So to reach O of log n, we need to implement the binary search algorithm. So which mean so binary search algorithm, and then so I think that pretty much it is just a binary search algorithm. So and find the starting index and the ending index. So not only one, and not only find the first index, we need to find two index of the target value. So let's go to the planning stage. So first of all, to create variables first, last, and mid. So basically, it should be a while loop. So while first is less than or equal than last, and so compare mid value with target value. So if mid value is less than target value, I'm going to first equals to meet plus 1, else plus equal to meet minus 1, something like that. So after that, as we find the target value, else if meet is greater than target value, else target value is 5. So after the target value is found, I need to search for the starting and ending in index. So probably I need to somehow around this index, I need to so basically I would do a while loop. Um, mm, was in the order of O log n. So maybe I'll do a while loop forward, while look backward to find the starting and ending index. And it it was kind of messy here, and maybe I can still use a binary search to do that. So find the find the index of the value that is not that's less than, just less than the target value or greater than the target value. Yeah. So after the loop, change the result. Basically that would be it, and um, so just A and B. So that is A and B, and So binary search algorithm, yeah, I should put it here. So I would say that the output, the start index, I will and index 0 to -1, and the first is equal to 0, last is equal to the length of a minus 1, mid equals to first plus last divided by 2. So well, first is less than or equal than last. To compare the values, so if A mid is less than B, first is equal to mid plus 1. Else if A mid is greater than B, last equals to mid minus 1. Else vector loop. So else I would do the so I equal to mid. Yeah, I equal to mid plus 1, while I is less than the length of A if A I is greater than target B. I'm going to mark it so n index will be I plus equal to 1. So if it is equal or less than B, it will keep adding the I. So after that we break this while loop. So J is equal to mid minus 1. So the same deal while J is greater than equals to 0. So if AJ is less than B, start index will be J. Else, I will just J plus equal to 1. J minus equal to 1. After this, I'm going to break. And after finding all this, we'll break it too, break the while loop too. So after that, I'm going to return the result. So return start index and end index. So still, like in this problem, so in this solution, this while loop, this two while loop here does not looks very good because the worst case you will have all of n. It takes all of n times. So that's a problem. And but anyway, I want to test it. So after that, I will try to do some optimization things. So A is equal to this. What? B is equal to 8. And wind search A and B. Yeah. So I set all the things up here and try to run it. It should give me 3 and 4. Nothing happened. It seems like it runs into the infinite loop. Yeah, I see. So if else if break, yeah, I forgot to the mid value, it doesn't change. So probably I should do this. So before that, 2, 5. That is not good. How come it's 2, 5? So I will going to test this in Python tutor and try to see what happens. That's annoying. So first is 0. Oh shit. First is 0, last is 5. That makes sense. And mid is 2. So first becomes 3. And then it finds mid is 4. And then so you find the target value already. So I is oh, I see. The problem I had is that I need to so every time I check this, it's not I, it's I. Since it's already greater than B, so I minus 1, and so aj is less than b, so it's j plus 1. So that would work. 3 and 4. So let me go back and test another. 3 plus 1, I minus 1, and go back and test another. So this a is here. So is 3, so it should print out -1, -1. So let's see. -1, -1. It seems like it works. And I'll try to put this result into this problem to see how it works. Um, it's running and 1. And it should return 0, 0 if it's not fine. 0. So while it's less than, why is it 0? So this is a corner case. So if since I set it I is equal to mid plus 1, and if it's already out of the scope, so yeah, that's a problem. And so how can I fix this? I is equal to mid plus 1. So if it goes out of the scope, and I think after this, before I do this, I may do like start index equal to mid and index equal to mid. So in this case, it will work. Let's try a is equal to 1, is equal to 1. It should print out 0, 0. All right. So seems I just need to add this to, because I already found it, so I can um, 118, 125. Oh, that's interesting. good. So while if a j is greater than b, that doesn't make sense. Why? If a j is greater than b, so an index would be that one. Let's try a simple one. So you should output 1 and 4. So it seems like it doesn't work here. So I is equal to mid plus 1. And while I is less than length of A, AI is greater than B. Why it doesn't work here? Let me try it again. So the mid is already 2, so I had to jump to the L, so star is the N index, and then mid is, so I is 3, so while 3 is less than 5. I plus 1. Oh, I see. So when it goes to the end, so when this while loop get to the end, it doesn't restart, but doesn't update the end index. I think the same problem would goes here, so maybe I just index equals to I. Before that. I think that will work now, so run it. Oh, 1, 1. That's interesting. Oh, that's not an index. Sorry. That's the start index. One, 4, it looks good now. Oh my God, it's quite a It's quite a bit here. And we're just doing manually, so. And index is equal to I. And then index is equal to J. So log of n time, log n time is still kind of not good, because if you have an input like if you have an input like 2, and you will still find it like literally go through one at a time to find the starting index and find the ending index. So maybe I will do some optimization here. So the thing is that the searching, it is searching, so it's still searching. So why not we just search why not we just write a method to search the start index and write a method to search the end index. So I'm not going to go over here right here. So this two while loop, they can absolutely be optimized to satisfy the Olaf log n solution. And yeah, that's it.